is now that we know our first and second derivatives, we find where they cross the x-axis, and then we set up intervals and we determine whether they're positive or negative on those intervals, which I'll show in greater detail. So we'll start off with our first derivative and set that equal to 0. And the first thing you can notice easily is that your e to the negative x can divide off, and basically you're just solving a polynomial at this point. Now that's complicated, and the best way of doing that is your quadratic formula. I'll skip the steps because it's just simple algebra. You can do it on your own. But you're going to get 2 plus or minus the square root of 10 divided by 3, which is equal to about 1.7 and about negative 0.38. So now we set up a table here. And we're going to have an interval from negative infinity to negative 0.38, from 0.38 to 1.7, and from 1.7 to positive infinity. And we're going to pick just any number along this interval here. And the reason we do it is we're going to cross the x-axis here and here. This is negative 0.38, this is 1.7. If we're positive at x equals 0, then we're going to be positive for this whole interval because we're only crossing the x-axis at these two spots. And if we're negative at x equals 0, we're going to be negative on this whole interval as well. So we put 0 in to our function f prime of x, and we determine whether we get positive or negative value out of it. So this is 0, 0 plus 2 e to the minus 0, so this is positive 2. This means that we're increasing. F of x is increasing. So f prime of x is positive, and f of x is increasing along this whole interval. And now we'll do the same thing, putting negative 1 into our first derivative and positive 2 into our first derivative. And what we get out is minus 5e and minus 2 e to the negative 2. So this is minus, this is minus, this is plus. So this is decreasing, increasing, decreasing. So this is a minimum, and this is a maximum. So we have a minimum occurring at 2 minus the square root of 10 divided by 3, and we have a maximum occurring at 2 plus square root of 10 divided by 3. And if you want to get the x and the y form of this, you just simply plug this value into f of x and you get the y value out to determine the actual points. Now we're going to do the exact same thing to find our inflection points. We're going to take the second derivative, set it equal to 0, and then do a table. And if we ever switch from positive to negative or negative positive on the second derivative, we get an inflection point. So again, the e to the negative x is going to divide out, and we're going to get 3x squared minus 10x plus 2 equals 0. That's going to be quadratic formula again, and it's going to be at 5 plus or minus square root of 19 over 3, which is approximately equal to 0.21 and 3.12. So we'll set up our table. And we'll pick some test values. We can do 0, 1, and 4. And then we put those back into f prime of x. If you put in 0, you get positive 2 out. If you put in 1, you're going to get minus 5 over e. And if you put in 4, you're going to get positive 10 over e to the 4th. But all we really concern ourselves with is the positive or negative signs. The positive sign means that we're concave up. The negative sign means we're concave down. And the positive sign means we're concave up again. So we have an inflection point here and here. So our inflection points occur at x equals 5 plus or minus the square root of 19 divided by 3. So now we've determined where our function is increasing, decreasing, where it's concave up, where it's concave down, where our minimums and maximums are, and where our inflection points are. So that's really everything there is to know about the problem. And in fact, if we pull up our graph here, right here, we're crossing, right here, sorry, this is where our first negative is, and this is at about negative 3.87, just like I said. I'm not putting it directly on it. If we go up here, we get, this is about our maximum, and that's about 1.72 again. There's 1.72. So y is 2.2. Right here, at about 2.1, this is where we go from being concave up to concave down. And if we go over to 3.12, this is where we switch from being concave down to concave up again. So we've solved everything there is to know about this problem, our inflection points, minimums, maximums. So send us any more questions if you have them. We love answering them.